Hello everyone, my name is Luna. Welcome to my presentation. Today I'm going to talk about how did I build a machine learning pipeline in one of the cloud platforms, Microsoft Azure. Here is the table of contents. The first part is going to be a brief introduction. Things include what services did I use, and the scope of the pipeline and my design idea. And the second part is a complete demo of the process of how did I build the pipeline. Just a heads up, there's going to be a lot of screenshots, but I will go through every single of it. The third part is the critical reflection. So basically, I'm going to talk about my feelings after generating my first own pipeline, and if there are any improvements on functionality of Microsoft Azure. And the last part is going to be a brief conclusion, which I will talk about some key takeaways and maybe some different perspectives. So for this machine learning pipeline project, I decided to use one of the datasets that I found online, which is called Titanic Machine Learning from Disaster. And I also put the link to the dataset to Kaggle below the figure. The reason why I choose this dataset is this dataset is kind of famous for machine learning purposes. And the purpose of this machine learning project is to predict whether this individual is going to survive given a set of features or variables. So the features or variables include such as gender, age, fare, their passenger fare, things like that. Okay, so obviously the cloud platform that I use is Microsoft Azure. The services and components I use in Azure include compute, analytics, storage, cloud storage, real-time analytics, data transformation. The reason why I use Microsoft Azure is that I think it's pretty easy and straightforward to use. So in Machine Learning Studio in Azure, I basically construct a predictive model just by dragging and dropping datasets and analysis modules onto the design surface. So it was not a hard process for me to build the entire pipeline, even though this is really my first time to do that. On the right side, I just put the quote from Azure. Azure Machine Learning Studio provides an interactive visual workplace that enables you to easily build, test, and deploy predictive analytics models, which I feel it is true after this project. Okay, so before going into more detail of the pipelines that I built, I want to talk about how was the pipeline designed, because since this is a fully DIY project, it was kind of important to get the very general framework of how I was going to design it. So in this project, the pipeline design process emphasized on two aspects. So the first one is the steps in the machine learning pipeline should include data pre-processing and data cleaning. So I did put a lot of efforts into pre-processing and data cleaning, which I will show you in detail later on. And the second thing that I emphasize on is how the data was going to be trained. As I mentioned, I didn't have real experience in this, so I tried a whole bunch of them, and I finally decided on one training method, which I will show you. And the last thing that I emphasized on is how the model was going to be deployed, which I will show you later. On the right side, you can see a figure which I generated. It's like the basic framework of the pipeline. So at the very beginning of my design process, I generated this figure so that I will know how my pipeline will look like. You can see at the very beginning, I have raw data set, and I choose columns, and I clean missing data, and I split data into train and test subsets, and I train with classifier, and I score the model with test data, and then I evaluate the model. That's basically the modules of my pipeline. Again, I believe I can add or take away some of them because there are kind of no rules of how this should look like. This kind of a first time try for me also, so I'll just share whatever I've got at the beginning of the design process. So lastly, I want to mention how did I decided the scope of this project. So I think scope is a very general but important term, which mainly depends on the purpose of the project. So for this simple project, the purpose is also very simple. It's just to predict whether someone's gonna die or survive as accurate as possible. So I won't worry to do much about the scope of this project. I just want to make sure I don't go out of the scope too much. That will make this pipeline very complicated. Okay, so that was a very brief introduction about my design idea and my objectives of the project. And now I'm going into the demo of this project. So I believe there are 12 steps in total that I've included in this presentation. So I will start from the very beginning. So the step number 1, obviously, I need to get into the Azure workspace. So that was easy. I just searched for Azure, and then I log in, and I click on the machine learning, and I see this option, or I see this page as the screenshot shows. So it says no Azure machine learning to display, which was true because I didn't do anything before. And from last page, I will click on the Create Azure Machine Learning button, and after clicking on that, I will see this page right here where I will create a workspace. I can name it, and I just basically create it. After creating my workspace, I officially getting into the Azure Machine Learning Studio as shown in the screenshot. So you can see there are a whole bunch of options, and the option I used is the designer, and I clicked on the Start Now, and then I can start uploading my dataset, which is the next step. Okay, so step 4, designer feature. This is the page that I use most frequently, so I decided to put a screenshot here. So this is a page where I clicked on the designer, and you can see on the left hand bar you can see an option called datasets, where I will click on the datasets and upload my data that I downloaded from Kaggle. Step 5, dataset creation. So continuing from the previous slide, I will upload my dataset. So I click on the Create Dataset button and I see several options. For this project, I will create my dataset from local files, which I can just upload the downloaded dataset. And after clicking on that, I come to the page, or I come to the screenshot that is on the right hand side. I will input some basic info, data store and file selection, setting and preview, schema, and confirm details. You can see, even though I haven't uploaded the dataset yet, it shows me a preview of the dataset, which is very convenient. In the schema page, where you can see all of the columns name, and then you can decide whether you want to include all of the columns or not. For this project, I decided to include all the columns for the schema, and then I just uploaded the dataset. So step 6, pipeline building. This is the really first step of my pipeline building process, and basically it's just for dataset purpose. So as you can see on the left hand side, if I go back to the designer menu, I will see an option that will let me to add a new pipeline. I just click on the new pipeline, and then I come to the page on the right hand side. You can see the Titanic train, which was the Titanic train dataset I just uploaded, will appear on the left hand side bar. I basically just drag it onto the workspace, which was really convenient. So after dragging the Titanic train, I would say module into the workspace, this is my raw data, right? This is my first step in my diagram that I showed you earlier. And then the second step will be select columns in the dataset. So there are some columns that I didn't want to include because I think that will affect my result or accuracy. So there's a module on the left hand side bar, which is not shown here, but it's basically the same location as where I dragged the dataset from. It says select columns in dataset. So I dragged the select columns in dataset into my workspace, and it led me to select columns in the dataset. You can see that the columns I've selected include survived, P-class, sex, age, siblings, spouse, part, ticket, fare, cabin. There are a couple of columns I didn't include because I didn't think that will make a significant impact on the result, or it will skew the result. Okay, so step 6 in pipeline building, which is to clear missing data. So after selecting the columns, I go back to the dataset page and I go to Explore on the top, you can see in the figure, and I go to Profile, and I will see this page on the screenshot. So if you look at the red rectangle, I circled the missing count, where the values are missing. So I click on the missing count, it will display the columns that has missing values in it. So in this case, the column age have approximately 170 something missing values in it. So I decide to delete that just for accuracy, because I didn't want to include any missing values in my dataset. Continuing with the previous slide, as previously, I just dragged the clean missing data module from the left-hand side bar onto my workspace. And then there will be a page saying columns to be cleaned. And as I showed on the last previous slide, I want to delete age because it has 170 missing values in it. So here I just put in age that I want it to be cleaned, and I click save so that I can successfully clean the age, and there will be no missing values. Okay, so that was my data cleaning process. Next step 6, pipeline building, split data into train and test. So obviously I want to split my data into train and test. So as previously, I just dragged the split data module from left-hand side bar onto my workspace. And then a page will come up and says fraction of rows in the first output dataset. So basically what it's saying is like how many percent that I want the dataset to be in the training. So I put 0.8, which means 80% data will be used for training, and the 20% of the data will be used for testing. Okay, so to get rid of confusion, I will show you how my pipeline look like right now. From very top is my Titanic train, so it's my raw data set, and then it's select columns in dataset, and then it's clean missing data, and it's split data. So currently I have 4 modules so far, and I do this by following the diagrams that I generated at the very beginning of my design process. So here I train my model. First of all, I will drag the train model module from the left-hand bar under the model training. So it was on the right-hand side, you see I have train model, the module on my workspace. And then I need to decide which algorithm I'm going to use. So under the algorithms, I was struggling for a bit because I'm not a mathematical master. And then upon a little bit more research, I decided to use a multiple class boosted decision tree to train this, because this is kind of a classification problem. Continuing with the train model option, so if I click on the train model module on my workspace, on the right hand side you can see will be a page pops up saying label column. I need to label a column. In this case, the labeled column will just be survived, because we're going to predict the survival rate. Not the rate, it's whether the person is going to survive or die. So in this case, the column names will be survived. So I think the previous step needs a couple of minutes, and after that I need to score the model and evaluate the model. This step is very straightforward. As previously, I just dragged the score model and evaluate model modules from the left-hand side bar and put onto my workspace and connected them with other modules to form a pipeline. Now I need to create a new compute target. So to do that, I just click on the settings, and then I click on the set up a compute target, and I just create a new one and I rename it. After creating this, I navigate to compute training clusters, and I will see provisioning state is creating. And I think this took a couple of minutes, and eventually it got approved. So the status becomes approved. Step 8, very exciting, submitting the pipeline. So on the right upper corner of the page, there is a submit button, which I clicked on that. And I think after like 10 minutes or so, it was submitted successfully. And as you can see, there are green check marks on every modules on my workspace. So my pipeline and my models has just been submitted successfully, and now I want to look at the evaluation of the model. So to do that, I just clicked onto the evaluate model module on my workspace, and I clicked on the output plus logs option, and I clicked on the log file. So this is the log file that it generated. As you can see, the overall accuracy is approximately 0.86, which means 86% of the time the model will predict correctly, which is pretty good in my opinion. So now I want to create an inference pipeline. On the right upper corner of the pipeline page, there's an option that says create inference pipeline, and under that I clicked on the real-time inference pipeline, and after a while it just basically generated a same pipeline for me, but on a separate page, as shown in the figure on the right. And I submitted again, and I waited a while, like 10 minutes, for it to be submitted. So model deployment. So this page just basically shows how my page looked like after I submitted my previous step. So the model is now deployed behind the REST API, and that is hosted on our Kubernetes service. And now I go to the compute, and under compute I go to inference clusters. I want to create a new inference cluster. So the cluster purpose is not production but dev test, but it wasn't shown on this screenshot. The purpose of doing this is that doing this will start to provision that Kubernetes service. So I did wait a little bit for these inference clusters to be generated, and after it has been generated successfully, I clicked on the inference clusters, and I see the Kubernetes cluster has been provisioned successfully, as shown on the figure. And step 11, deploy new real-time endpoint. So if I go to the real-time inference pipeline that I just generated, and on the right upper corner, there will be a deploy button, which I will click on. And after click on the deploy button, a page will pop up saying set up real-time endpoint, which I will do that. I will choose the deploy new real-time endpoint, and I give it a new name, and I click on the deploy button. So this takes about 10 to 15 minutes for my computer to run, but it finally runs successfully. Step 12, testing. This is pretty exciting for me. So far, I have deployed my pipeline, and now it's time for testing using my testing data. So on the left-hand side bar, I click on the endpoint, which I just generated a real-time endpoint, and I clicked on the Titanic endpoint. A page will pop up on the right-hand side. You can see there's a blue button called Test, which I will click on. I basically click on the test, and the result will be reviewed on the next page. So this is the testing result that is from my previous slide. So as you can see here, the data has been successfully supplied to the deployed model. If you look at the last row of the page, it says scored labels 0. So scored labels equals to 0 means that the passenger is likely to have died, or the survival rate is likely to be 0. Okay, so that concludes my pipeline building process, which was really fun. And now I just want to talk about what I feel after building my very first pipeline ever. So in my opinion, the deployment and testing are more intuitive activities, while model training can be more complicated. But again, this is for me only, and I think the reason why I think the model training part is kind of complicated because there are so many algorithms that I can use. For example, there are regression, clustering, classifications. Like, even though I knew this was a classification problem, there were so many, I think like 10 classification algorithms to choose from. So it is not that user-friendly for a first-time user, so it looked a little bit complicated for me. But the deployment and testing are very intuitive, and I found it was straightforward to use. And how can functionality to work on MLOps pipelines in Azure be improved? So I did do a little bit of research on this, and I found that some paper talks about oftentimes the workflow is handling the scenario of imbalanced dataset and will result in skewed results. So an imbalanced dataset is characterized by having more instances of a certain class compared to others. There are definitely solutions proposed to solve the problem. So I think the author Garler and colleagues showed that combining random undersampling techniques will resemble models stands out among other data level solutions. And solutions to deal with an imbalanced problem at the data level involves oversampling the smaller class or undersampling the larger class. So in the future, I hope to explore this idea by incorporating an undersampling techniques to the existing models in the workflow. In conclusion, in Machine Learning Studio, you can construct a predictive model by dragging and dropping datasets and analysis modules onto the design surface. You can iteratively build predictive analytic models using experiments in Azure Machine Learning Studio. And each experiment is a complete workflow with all the components required to build, test, and evaluate a predictive model. And finally, potentially, adding additional models to deal with imbalanced dataset can enhance the functionality of Azure Machine Learning. This comes to the end of my presentation. Again, I really had fun during building my very first machine learning pipeline, and I hope I will have an opportunity to continue and do this in the future. Here's my reference. Thank you so much for watching my presentation. Have a good day.